So welcome to our third lesson here from Unit 1516, Problems in Measurement. And what we want to look at today is we want to look at calculating the volume of objects. So what do you need to be able to do at the end of this lesson? Well, you need to be able to determine the volumes of shapes like spheres, prisms, cones, and cylinders. And in some cases, that's going to involve applying the Pythagorean theorem to solve for some unknown values. So let's start off with a straightforward example of calculating the volume of a sphere. What you want to have beside you as you're going through any of these questions is you want to have a calculator, because these are going to involve a lot of calculations, and you want to have your formula sheet. So if you don't have your formula sheet, make sure you ask your teacher for one, because you get to use that formula sheet on your unit test and on the final exam and on your EQAL. And the formula sheet obviously lists the formula for all of these volume calculations that we're going to do. So for instance, if we're looking at a sphere here, the formula for the volume of a sphere, if you look it up on your formula sheet, it might say something like volume equals 4/3 pi r cubed. And the way you want to think of that is, instead of thinking of that as 4/3, some people find it easier to think of it as the volume is 4 times pi times r cubed divided by 3. And you want to keep in mind also that this r cubed here, the cubed means r times r times r. So not r times 3, but r, whatever your radius is, multiplied by itself 3 times. So here's our example here. Find the volume of this sphere, and we've got this line here going all the way from one edge of it to the other that says 28 meters. So when you see that line going all the way across, they're telling you that that line there represents the diameter. Diameter goes from one edge to the other. So our diameter is 28 meters. To use this formula, we need to know what our radius is. So our radius, or r, is going to be half of our diameter, because the radius starts at the center, goes out to the edge. So our radius is going to be 28 divided by 2, or 14 meters. Now we just want to put that value into our formula. So our formula here is volume is 4 pi r cubed divided by 3. And let's substitute in our value for the radius. We've got 14. We're going to cube it, and then we're going to divide by 3. And this we can just do all in one step in our calculator. 4 times 3.14 times 14, doing the cubing, and then divide everything by 3, and we get 11 million, no, not 11 million, that's going to be 1,148,821 centimeters cubed is our volume. Okay? And the units are important. If it's a volume, it's got to be something cubed. So there's the volume of our sphere. Another shape might be prisms and cylinders. Now, prisms and cylinders have something in common. They both have some sort of shape as their base. This is a picture of a prism right here. So we've got a base down here at the bottom. In this case, our base is a rectangle. And it has sides that go up vertically, okay, straight up and down. For any object that has sides that are vertical, so you have some shape for the base and vertical sides, the formula for the volume is going to be volume is the area of that base times the height, or the height of those vertical sides. So for our first shape here, we've got a rectangular prism. And it's called a rectangular prism because the shape of the base is a rectangle. So if we figure out the base, let's say the base area, well, we know our base there. I've got it shaded in blue. If it's a rectangle, we have to do length times width. So that's going to be 12 times 6. 12 times 6 is 72. Now, if I want to figure out the volume, That's going to be area of the base times height. So 72 is the area of the base. What's our height here? Well, it's 9 meters. So 72 times 9, which is going to get us 648. And let's check our units here. Our height, our length, and our width are all in meters. So this has got to be meters cubed. Okay. Let's look at our next shape here. We've got a cylinder. Switch colors here. We've got a cylinder here. Now, same thing for a cylinder. We want to use this formula. Okay. Area of the base times height. Now, what shape is our base? This cylinder here is kind of lying on its side. Okay, so we've got to imagine taking this thing and, turning it up so it's kind of like this. Then we can see that our base is a circle there. So base is a circle. So the area of the base is going to be pi r squared. So what we need from this thing here is we need the radius of that circle that represents our base. Well, the radius there is 8 meters. That's our r. So we have pi 8 squared. So the area of the base is going to be, multiply that out on our calculator, 200.96. And our units are not centimeters, but meters. So meters squared. Now to get the volume, we're going to do the area of the base times the height. So 200.96 times, what's the height of this thing? Well, again, if we imagine it, again, tipped up on its side, the height is going to be that 22 meters. So we just multiply that out, and we get 4,421.12, and our units are meters cubed. Okay. So there's the volume of our cylinder. The last two examples here are going to involve cones and pyramids. Now the difference between cones and pyramids and the cylinders and the prisms that we saw on the last page is that whereas the sides of our prisms went straight up and down, for a cone or a pyramid, all of our sides meet together at a point. And there's a pyramid there, here's our cone, everything, we've got some shape for the base, and the sides all meet in a point up at the top. So if the sides of the object meet at a point, the formula for the volume is, it's related to the formula that we had before. It still involves the area of the base times the height, but instead we have a factor of 1/3 out front. Or we can think of this as area of the base times the height divided by 3. So let's look at our first example here where we've got a pyramid. It's a pyramid because the sides of it are triangles, and this is a rectangular pyramid because our base is a rectangle. Our base is down here. So we are given the length and the width of the base, and we're given the height of the pyramid right up the middle here. So we can easily figure out for our base, area is just going to be length times width because our base is a rectangle. So 6 times 9, or 54 meters squared. So our volume is going to be that area of the base. Let's say area of base, let's write up the formula here. Not divided, my mistake, just area base. So area of the base times height divide by 3. So if the area of the base is 54, the height of the pyramid is vertically up the center there, so that's times 12. We divide that by 3, and we just put this into our calculator, and we get 216 meters cubed for our volume. We can do the same sort of thing for a cone. Okay? We know this is a cone because it has a circular base. So if we want to find the area of the base, we have to use the formula for the area of the cone, pi r squared. So we look at our cone here, and they're giving us 18 meters from edge to edge. So that must be our diameter. So our radius must be half of that, because it goes from the center out to the edge. So it's got to be 9 meters. So we want pi times 9 squared. And we punch that into our calculator. Pi times 9 squared is 254.34, and that's going to be in meters squared. So for our volume, again, we want area of the base. So we'll just put in the 254.34 times our height. Let's see, our height is starting from the center and going straight up to that vertex vertically. So this is going to be our height, 24, and then we want to remember to divide that whole thing by 3. So 254.3 times 24 divided by 3 will give us 2,034.72 meters cubed. And that's our volume. So we should probably get in the habit of sort of putting a box around these things to let us know that it's our final answer. Back here, this was our final answer up here. The last one here that we're going to do is a little bit trickier. Okay, this is another cone here. So we want to use the formula again. I've identified this as a cone. We want to use, again, area of the base times height and divide this by 3. Let's do our base area here. Let's see, they give us the radius. We know this is pi r squared. Our radius here is 5 meters. So pi times 5 squared gets us an area of 78.5, and that's going to be meters squared. We want to take the area of that base and multiply it by the height. Now our height has to go right down to the center of that base there. They don't give us a value for the height. Okay? We don't know what that is there. What they give us instead is this length over here, which is our slant height. We can't use the slant height in this volume formula, so we need to calculate what our height is. Fortunately, what we see outlined in blue there is a right-angled triangle. So we can use the Pythagorean theorem to figure out what our height is. So we label our sides again. If we're using Pythagorean theorem, we always think of these as C, A, and B, and we want to use C squared equals A squared plus B squared. So we can put in our numbers here. Our C is 9 meters, so we're going to have 9 squared. A is our height, so we can put h squared. And B is the same as our radius, so we put in 5 squared. And now we can solve this. 9 squared is 81. We'll still have h squared. 5 squared is 25. We need to subtract 25 from both sides. So we are just going to do minus 25 because we want to get this h all by itself. So that's going to leave us with 56 equals h squared. So h is going to be root 56 or 7.48, punching that into our calculator. Now that we have that height, we can combine it with our area of our base to get our volume. So our volume is going to be area of the base, 78.5, times height, 7.48, divided by 3. Punch this into our calculator, and we get 195.73, and our units are meters cubed. And that is going to be our final answer.